To create an equation, you first have to know what you want the answer to be. So if I'm starting with July 3rd, that means I want the answer to be 3. I'm first just going to start with a regular x. Then I have to decide, am I going to go with distribution, or am I going to put a number in front of x? So for this one, I'm going to go ahead and go with distribution. So I'm going to put my parentheses, and then I'm going to pick a random number to go in front of the parentheses. I'm going to go ahead and go with -4. Then I want to do usually x plus or minus a number. I'm going to do +7. And then after that, I'm going to put some equal signs. Then I'm going to add another x on the other side of the equal sign because usually you have variables on both sides. I'm going to make it 2x. Again, all of this is completely random. You want to make it random until you get to the very end. At the end, we usually have plus or minus a number. I'm going to just leave a box, an empty box, because in order to make it equal to 3, we have to put something specific in that box. So once you have a random equation made like this, now is where you plug in 3 for x. So I'm going to write the same exact thing again, except instead of x, I'm going to put 3. So now here's the 3. +7, everything else will be the same except for x. It will be 3. And I'm going to write the box again. Actually, I don't need to write that really. I'll just leave it like that for now. Once I have 3 plugged in for x, I'm going to work it all out to see what I have so far. So I know that 3 + 7 is 10. And this is 10 times a -4, which would give me -40. And then 2 times 3 is 6. So basically we have -40 is equal to 6, and because I know it's not, I need to put something in this box to make it equal. Now when I get to this step, what I usually do is I subtract over here on the right side. Because this is a +6, I'm going to do the opposite and do -6. And putting everything on one side gives me -46 is equal to -46. That's exactly what needs to go in that box up there. Now I know it seems a little bit confusing and you're not really sure, does it actually work out to be x = 3? Now this is the part where we prove it. This is just creating the equation, but you know that on your work paper you have to prove that your equation actually equals the day that it's supposed to match. So I'm going to write it all out. X + 7 is equal to 2x - 46. And now if I work this out, it should equal 3. So I'm going to start by distributing, and I get -4x - 28 is equal to 2x - 46. I know that -4x is the smaller variable, so I'm going to do the opposite of that. I get -28 is equal to 6x - 46. I'm going to add 46 on both sides. Remember that different signs means that you're going to subtract. So I'm going to actually end up doing 46 - 28. Remember, you do the bigger one minus the smaller one. You can use a calculator for this, but it's really not that difficult where you have to. And then you end up here, and you know that if you divide by 6, you will get x equals 3. And so this right here is actually a 4-step. Our first step is distributing. Our next step is adding 4x on both sides. Our next step is adding 46 on both sides. And then our last step is dividing by 6. So if you make a formula like this, where you have distribution and then x on the other side, and then you're missing a box with a random number that you figure out at the end, that will give you a 4-step every single time. So now I'm going to show you a couple more examples. I'm going to make one for July 4th because this is not the only way that you can make it. There are other ways you can make it look. So I'm going to do one where x is equal to 4. I'm going to first start with x. Then I'm going to put a random number in front of x, like -2. Then I want to usually add a constant with it, which would be just a regular old number without x. So I'm going to put a -11. And then you want to have combining like terms on one of the sides. You can make it on the left side of the equals, or you can make it on the right side. It doesn't matter. I'm going to go ahead and put it on the left side this time. Now you can add another x term like plus 5x so that it combines with the 2x, or you can put another integer so that it combines with the 11. So for this time, I'm going to put another integer that combines with 11. Now that you have your x term, your two terms that combine, now all you need on the other side is another constant and another x term. So I'm going to make, I don't know, like 5x. And then before we get to that last term, this is where we write that box that we won't really know what to write there to make it equal until we work it all out. Now we know we want x to equal 4. So this is the part where we write everything the same, but instead of x, we're going to put a 4. Okay, so I'm making it exactly the same. Here, this is all we have. So 4 times negative 2 gives you negative 8. And then 5 times 4 gives you 20. If you combine all of those, these two negatives, you add together to make negative 19. And then negative 19 plus 3 gives you a negative 16. And now I need something to add in this box so that it will make it equal. And again, what I do is I just do the opposite of what's on the right side. Since that's a positive, I do negative. And I end up with a negative 36 is equal to this box, which means that's what goes in the box, negative 36. And that's what goes up here. So now we made our equation. Here is where we prove it. So I'm going to write that exact same thing in this box. And then I'm going to work it out. If I'm correct, then this should equal 4. So I'm going to start by the combining like, I'm going to start with the combining like terms on just the same side. That gives you negative 8. Then the smaller x term is negative 2x. So I'm going to add 2x on both sides. Then I'm going to add 36 on both sides. These are different signs, so I have to subtract. And then if I divide by 7, I get x equals 4, just like I planned. So again, remember that you start with just a random x. You make your equation pretty much as crazy as you want it to be. If you go with the distribute route like this, then your equation should look like this. You need an x term on both sides. Whoops. You need a constant, and then you're going to need that box where you figure out what goes there at the end. If you go this route where there's no distribution, then you need to make sure that there's at least 2 terms on the same side that you can combine. Otherwise, it's going to be a 3-step and not a 4-step. So make sure that you're making your equations and you also prove it so that you know it really does equal that day number. So I'm going to do just one more, and this one will be an inequality so that you can see how that's done. And I'm going to make this one equal to 11. So I'm going to go ahead and start with x. And this one will be a little bit different because I'm going to put a negative number in front of x. It's going to be a negative 3. And remember that when you're doing inequalities, if you multiply by a negative number, you have to flip the symbol. So if we started with just x and just a less than, because there's now a negative 3 next to it and being multiplied by it, this symbol now has to flip the other way, like that. Now, I'm not going the distribute route, so I'm going to make it look like this, where I need 2 terms on the same side to combine. So I'm going to go ahead and put those 2 terms on the right this time. For this side, I'm just going to put like a plus 5, but over here, on the right, I'm going to do a 4x, and then a plus 8, and then what goes in this box will be what we figure out after plugging it in. Okay, so remember I flipped that symbol because of this negative that's being multiplied with x. So remember, x should equal 11, so I'm now going to plug in 11 instead of x. so I can see what I need to add in that box to make it all equal again. So negative 3 times 11 is negative 33. 4 times 11 is 44. This is what we have so far. Different signs mean subtract, so I'm going to get a negative 28 here. And 44 plus 8, that'll give me a 52 here. Now to figure out what goes in that box to make this perfectly equal, I'm again just going to do the opposite of that right side. So I'm going to do minus 52 on both sides. And because they're both negative, I'm going to add them. That ends up giving me 80 even, negative 80. And that's what should go in that box. But let's go ahead and check it because, you know, mistakes are very common. I make them too, often. You guys know that. So I'm just going to double check myself and make sure that this does in fact equal 11 in the end. The sign doesn't really matter. The symbol isn't what's important. I do want you to solve it correctly, but we want the number at the end to be 11. So now I'm going to combine like terms on the same side here. Those are different signs, so I subtract. And I get negative 72. Now negative 3x is the smaller one, so then I'm going to add 3x on both sides. I get 5 is greater than 7x. And then I add 72 on both sides. And I end up getting 77. I divide by 7, and then I get x is less than 11. Which, if we look at our original equation, it was x less than 11. And so that flipping, the whole action of flipping, sorry, being called, does work. So please use this video. It will help